What you are looking at are a series of fascinating and picturesque geologic formations adjacent to the village of Gurím in Turkey. Nicknamed fairy chimneys, these tall pillar-like features tower above the surrounding landscape in a vertical manner by as much as 35 meters or 115 feet. And some of these fairy chimneys have what appear to be precariously placed darker boulders on their tops. While these features might look like the hoodoos seen in Bryce Canyon National Park, they in fact have a completely different origin, as they are not truly sedimentary rock via sandstone and limestone. Rather, they are largely composed of ignimbrite, volcanic ash, and layers of lava which are deposited over millions of years in some of Turkey's geologically recent largest explosive volcanic eruptions. Thus, these pillars ended up forming only because a section of ground happened to be located downwind of numerous large-volume eruptive centers which, when compared to surrounding regions, deposited the thickest amounts where the fairy chimneys are currently located. This would be somewhat similar to being 0 to 5 miles east of the summit of Mount St. Helens, which is most likely in the United States portion of the Cascade Range to be inundated with a layer of tephra at least 1 centimeter thick on any given year. Something similar was true in Turkey, as prevailing winds blew in ash from numerous volcanic centers which produced at least 15 eruptions, rating the volcanic explosivity index as a 6 or a 7, registering in as 7.7 to 120 times larger and more explosive than the 1980 eruption of Mount St. Helens. While only a fraction of the relevant volcanic centers are still active or potentially active today, several remnants of these powerful volcanic eruptions still exist via vast calderas, such as the 160,000-year-old and 15-kilometer-wide caldera at the Akigol Nevşehir volcano, or the 2.52-million-year-old and 18-kilometer-wide caldera at the Erciyes Dağ volcano. However, there is another important factor to consider which aided in the formation of the fairy chimneys. The region where they formed was surrounded on all sides by higher terrain, and due to the topography of the area, any large volume pyroclastic flows produced by an eruption would largely be directed towards that very location. For context, pyroclastic flows are superheated currents of primarily gas which also contain lava and ash. These currents can move at speeds exceeding 200 km per hour, and during eruptions of a VEI 6 or 7 magnitude can reach as much as 70 km or more from a volcano, scorching the landscape along the way. Since pyroclastic flows are not completely gas, they carry with them large fragments of rock and finely grained ash which piles up in natural low points. During truly voluminous eruptions, the rock type deposited behind is known as ignimbrite, which often has a brown to tan coloration, like seen due to the 1912 eruption of Novaropta in Alaska in the Valley of 10,000 Smokes, or in Turkey representing a much older sequence of ignimbrite layers at the fairy chimneys. These chimneys are largely composed of ignimbrite produced by eruptions between 9 million and 100,000 years ago, with different layers of ignimbrite being easy to spot due to slightly different colorations, appearance, and how easily they erode. Over millions of years, what used to be a uniform thick layer of ash was eroded into a series of tall ash pillars, somewhat like the Chiricahua National Monument in the U.S. state of Arizona. However, these ignimbrite layers do not explain the mysterious harder caprock, as the majority of caprock represent layers of harder basaltic or rhyolitic lava which once flowed over the landscape. Thus, the inclusion of these lavas protected the more brittle rock beneath it. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank Jeff Groves for increasing their Patreon tier on this channel's Patreon page.